in the code is I thought I did. This should be D. Because we list them out, I list them out for you. Right? So here are the observations that have those large D statistics. And what you might do, what I would do next, was I would go back and look at each of these values. And I would say, are these reasonable values? I would go back to the source data and say, are these real values? Then the other thing I might do was I might go back and drop each of these variables, sort of one by one, and see what the effect of dropping this particular observation is on the regression equation. I want to see how much influence each of these observations has on the outcome. Because it only takes one observation to change the shape, the surface of your regression.
And that Cook's-D showed you that the longest one would have the most
influence.
Yeah. So if you drop that, potentially
things could change dramatically. So what I would do in that case, if I were to write this up for a journal article, I would talk about how I did this regression, I diagnosed it, I found this one massive outlier, I removed it, and here are the results from both regressions. If they're the same, great. If they're not the same, you have to talk about what are the implications of ignoring that real observation. You could say, yes, this is possible, very rare in the clinical setting. I'm not worried about it. Right? But that's a reasonable thing to do.
So these should be the same ones as you would have picked up if you had analyzed your studentized residuals.
Probably.
Could you do one or the other? Which one
you
is
gotta do them all.
You gotta do them all.
Yeah. Because there's lots of things that are going on here.
Yeah. But you use the Cooks in order to flag which ones rather than the studentized ones to flag the residuals that are outliers. Okay.
I would talk about the studentized residuals to show, or at least I could count the number of values above an absolute value of 2 to say what percent of those values are above 2, right? So if I have 400 values and my alpha was set at 0.5, that means I would probably have on average about 16 values that would be above 20 values. Where am I getting this number from? So if I had 100 observations, I would expect 5 values to be outside the range by chance, right? So if I had 500 values, I would expect 5 times 25, or 5 times 5 values to be out of range, right? So I could say, well, with 468 values, and let's say I had 20 values out of range, I would expect that given my large sample size, right?
Mm-hmm.
But if I had 100 values out of 50 to 500 values that are way outlier-ish, then we have a problem. This is why, again, I spent all that time on the basics, because to interpret this stuff, you really have to have a good understanding of the basics. Okay, so let's talk about leverage, and this is where we will stop. This is a leverage plot. So these, I remember this is the same order as it was before. So here we have this big out. It's the same outlier. It's the same point. So these values have leverage. So these values above the red line are not outliers on the y variable, but they are outliers on the predictors. These outliers on the predictors are far away from the mean of y, and therefore could make that seesaw go up or down. Again, what I would do here was I would individually remove these in some sort of sequence and see what the effect of removing these values with significant influence have or leverage has on the regression equation. Okay? So I'm going to stop here and just leave you with a thought. Getting a set of data and cranking it through the computer, we're going to get an answer. Clearly we got an answer. We can interpret those answers. What I'm begging you guys to do is take that next step and think about the consequences of not examining what you've done in trying to describe the world. Right? Because our inference was physical health and stress can predict 20% of the variability more or less in number of doctor visits. Mental health has no effect, right? And a lot of people just stop there. They don't go through this exercise to say, well, you know what? Maybe my model of the world doesn't agree with what I observe in the world. And therefore, if these two things don't agree, I have to decide which is wrong. And what is the effect of my inferences? What am I trying to say based on my data from what I observe in the world? Right? That's what I'm really trying to get you guys to think about.
A lot of journals stop. And I feel like I don't read a lot about the other.
Yeah, of course not. That's what I'm saying is that, you know, the computer will give you the answer or give you an answer. It's up to you, the human being, to talk about the reasonableness of the results.
Actually, I've read some articles that actually go through, and it's just a simple one that says we also analyze for multiple this and that. So some articles clearly do it.
The others don't do it, they just don't write that.
What do you think? What do you think?
They don't do it?
I don't